Hello, people. How you doing? I hope you're doing really well. So let me fix this so I can see myself clearly on the screen while I speak to you. All right. So today, what you're gonna understand is training data and the test data set. What's the difference? We already understood what supervised learning is, what unsupervised learning is. This time we'll understand what is training data set. We'll understand training dataset, and we'll understand test dataset. These two major concepts. So let's say, and we'll understand it through the lens of linear regression. Okay. Through the lens of linear regression, we're going to understand the training dataset and the test dataset. So let's say we have a dataset which consists of x and y value. And what we have to do is we have to train our model based on the x. We have to train our model based on the x. What do I mean by based on the x? X is going to be our independent variable, and y is going to depend on the x. Meaning that when we give it the value of x, we give the system the value of x, it should give us a predicted value of y. It should predict the y. So to be able to do that, what we're going to do is we're going to come up with an algorithm. We're going to come up with an algorithm, and using this algorithm, we need to train a model. How do you train a model? We give a a set of data to our algorithm. We ask it to train it, and the trained data is a model. So what is a model? Model is our trained data set, or like our trained system is a model, right? So let's say we give a set of data to our algorithm, and the set this what this is actually going to tell the algorithm is that, see, for each value of x, these are my value of y. So let's say we take up until this training set, up until this is it is like a training set, right? So this portion is the training set. What we're going to do is we are going to use this training set to train our algorithm, train our model through the algorithm, right? This algorithm is going to use this part of data to train the model. So what it actually is going to do behind the scene is that this algorithm, it follows a set of certain formula, algorithmic form, mathematical formula in our case, which is going to be y equals to mx plus b. This is the formula this algorithm is going to follow. All right. So what this algorithm is going to do is it's going to figure out the value of m and figure out the value of b, and it's going to take the figure out the value of m and figure out the value of b, obviously. But how does it going to do that? It's going to figure out the value of m and b based on the training data set. See, in the training data set, we have x and we have y. And in a later video, we will try to find out how to calculate m and how to calculate b. It is going to be the topic of the next video, but today we're just gonna, understand and take it as it is that, the somehow the algorithm is gonna find out the value of m and find out the value of b based on the training data that you give. You don't give the whole of the data set, you give a portion of it, a subset of the data set, which is x and y. You give it to the algorithm. this training data, you give it to the algorithm based on the data, based on the subset of x and y up until 1 to 9, 13 to 21 for y. Subsequently, for x and y, you give it to the algorithm. It figures out the value of m and figures out the value of b. Then it predicts the value of y for a given value of x. It predicts the value of y for a given value of x. So every time you give it an x, so it's kind of like that. So it has x, let's say it doesn't know the value of x and it knows the value of b. So it figures out, like, from the existing data, from the training set, it gets the value of m and it gets the value of b through a calculation. So the computer does a calculation, this algorithm does a calculation behind its brain or inside its brain, and then it somehow predicts the value of, like, every time you give it like the value of x, it will give you like a value of y. So this is going to be y, right? So this is how it actually works behind the scene. But to be honest, you know, mm, once you give the value, once it trains itself based on this formula, which is called mx plus b, it figures out the value of m and it figures out the value of b. It, in its brain creates another different set of uh, let's say a model, another different set of x and y based on this value of m and based on this value of b. Like sort of like it sort of like builds like a model, like a different model, right? So not necessarily, we don't really have to understand this part, that it builds a different model. You don't really have to understand that. Uh, but what we can say is, like, when you give it an algorithm, um, you train the data set based on the algorithm. It has a brain, and in the brain it has the value of like m and value of b figured out. So now comes a part of the prediction. So how does, it would predict the future values of uh, x and give us the value y? How does it predict the future value of x based on this formula? So what it has now is a model, right? It has a model. After the algorithm, we get a model, because once we have this m and b defined, then we can call it a model. So we have a model now. So what this model literally does is, every time you give it like a, you know x value, it will give you y value. So the model is basically something that stores value of m and value of b, and every time you give it a new value, it dynamically processes the data and gives you the value of y based on this formula, right? So the model, in the core of the model, this is the formula that works. In the core of the model, this is the formula that really works. Mx plus b, and it has a value. Let's say it has a value of 49 into x plus 0.5. So this is like arbitrary value that I have just assumed here. So let's, you know, assume that the value of, let's say we run the algorithm, we develop a model, the model is going to have a value of m, which is equivalent to this, and a value of v, which is equivalent to this. So every time you give it like a new x, so it would just multiply the new value of x. Let's say you give it 10, it would just multiply the 10, and then it would give you a value of y. So for that, for the respective x, which is our 10, right? So similarly, what we did over here is, we did the same. We, if you remember, we took the training set, but we left some of the data. We did not take the whole of the data set, right? So we left some of the data untouched over here. This is untouched data. We didn't do anything with this data. But this time, what we're going to do is, we're going to see if our model is working properly or not. So what we're going to tell our model is take these values, when you give a model these values of x, we want the model to take these values and we're asking it to generate and predict y. We're going to ask it to predict y for each of these x values and give the value to us. What this model does, it goes back to its repository or the formula and it calculates the value of y for each of the respective x, and then it gives us this value, right? This value. So if you remember, we have like this new value from the model for x, but we also had some original value of y for the values of x in the test set, right? We had some original value of y, right? But what's the use case of this original value of y? Say y hat is the original y. What's the use case of this value? What this is going to do is it's going to help us find out how accurately this model predicted the value. So what we do is we find out the accuracy. How do you find out the accuracy? We calculate the error. How do we calculate the error? We subtract the y predicted, which is this, from original. See, from the original. This is our y original. We subtract the y predicted from the original and we see what's the difference. What was our original value and what's the predicted value for the same, you know, data that we gave to our model. Then we compare and we see if it's the same or not. If it's the same, then model was accurate. If it is not the same, then model wasn't accurate. So what we do is we try to find out the accuracy for the value of x, right? What we're going to do here, we're going to take the original value of x for the 10. Like we're going to take the original value of x, which our original value of 10 is going to be what? 22. See, 22 is going to be our original value of x. And now we subtract the predicted value of x, which is 25, and it is 3. So it is not accurate. It is not 100% accurate. It's very close, but not 100% accurate. So this is what we call error. Obviously, it's going to be minus, but it doesn't really matter whether you give it a value or not because it's still going to be the difference. We're going to calculate the distance only, nothing much. So we have an error here. So this error is equals to 3. So this is how the whole model really works. This is the objective of training a data set, which helps us find out the value, the algorithm to find out the value of M and then and the value of B. And then we give it a value of X. In the future, from our test data set, it predicts Y. It predicts Y. And then from the ypred, we subtract from the ypred, we subtract the value of y original, we see our error. This error is also called cost function. So we want you to understand and really know that this error is going to be called cost function, and this is going to have some implication down the line in our next tutorial. So I think that's it for today. I hope very well that you understood what is a training data set, what is a test data set, what is like the algorithm, what's a model, and how does it work. So I hope you really understood it. Yeah, so thank you.